Continue looking at linear inequalities with absolute values. So in the previous video we had considered the problem 2x minus 3 is less than or equal to 5. Let's consider what would happen if it were greater than or equal to 5. Well, before we do that, we should consider what would happen if x were greater than, the absolute value of x, were greater than or equal to 5. In the previous video, when it was less than or equal to 5, we saw that it had to be sandwiched between plus and minus 5. Let's consider what happens in this case. So we should look at, we're clearly interested in the points negative 5 and 5, since we're working with an absolute value. And let's consider some points in between. So once again, let's consider 0, negative 10, and 10, and flesh this out. So let's try negative 10, negative 5, 0, 5, and 10, and determine if it makes it true or not. So if I were to substitute negative 10 into the absolute value sign, I would get 10 is greater than or equal to 5, which is clearly true. Substituting 10 in will accomplish the same thing. When I substitute negative 5 in to the absolute value signs, I get 5 is greater than or equal to 5. Since equal is included, that would be true, as would 5 would also make it true. 0, on the other hand, is not greater than or equal to 5, and so that would make it false. In fact, let's consider negative 1 and 1 as well. Negative 1, when you take the absolute value, is 1, which is not greater than or equal to 5, so that is false, and false again. So in this case, it looks like we have the opposite solution. Everything between negative 5 and 5 is returning a false statement. Everything outside of negative 5 and 5 is giving us a true statement. So the solution seems to be anything bigger than 5 or less than negative 5. So notice in the last case we had an and statement. The values had to be between negative 5 and 5. In this case, they have to be less than, negative 5 must be less than x. I'm sorry, let me reverse that. X must be less than negative 5. Or, keyword being or, x must be greater than 5. So values like negative 10 are less than negative 5, and values like 10 are greater than 5. So our solution includes 5 and negative 5, so we can put nice full dots there, and then everything outside of the region in between. Anything in between will end up giving us false values, so we exclude everything between 5 and negative 5. Now let's go to the more interesting problem that we started with. This means that if we have an absolute value is greater than a number, then what is inside of the absolute value must be less than the negative of the number, or it must be greater than the number. So let's continue solving this. We'll solve them exactly the same way that we did before. We want to add 3 to both sides. So we're left with 2x is less than negative 2. Divide both sides by 2. And we're left with x is less than negative 1. When we look at the other side, we would add 3, the other possible solution. And we have, therefore, 2x, that was a minus sign right there, must be greater than 8. So x must be greater than 4. And keep track of this, there is an or sign. So if I were to plot this solution on the axis, I will do it down below. X must be less than negative 1. So here's negative 1. In fact, it was greater than or equal to, so I should include the equal sign. throughout the calculations. So when I look at this, we would have to be less than -1 or greater than 4. So notice the or statement is what we want because we want to be on either side of -1 and 4 and not in the interval in between. So when working with absolute value signs, we want to use the and statement when we're looking at the values in between and the or statement when we're looking at the values outside of given points.